So what I'm going to do is I'm just going to run through how this works and how we calibrate it, and I'm going to talk about how we use these cylinders as well. So I'm just going to go through step by step how to do it. Almost ready, or have you already started?
I'm already started.
Okay, good. So the first thing we need to do is we need to calibrate our gas analyzer. So this is the gas analyzer. We haven't used this before. So this is an Worx gas analyzer that we're able to hook into the Worx TA. So there's just a simple I-wire connection that goes to the gas analyzer to the TA. This gas analyzer is a little bit different than other gas analyzers because it doesn't display what the value is for the oxygen and CO2 concentration, but what we're able to do is we're able to take that information and display it on our computer. So the nice thing about this is it's very compact. It also has two different sensors in it. So it has a sensor for carbon dioxide and it has a sensor for oxygen. So it works out extremely well. You can probably hear that it's making a noise. And the reason for that is there's a pump inside that draws the sample through. So it's sampling at a rate of 200 milliliters per minute. So in order for you to get the sample into the gas analyzer, it has to move through. So if you breathe in or if you're sampling something, you want a pretty good time between when you blow into it or when it samples to when it registers. So it's drawing air through continuously at 20 milliliters per minute in order to sample that. So it's hooked up and it's ready to go, but like everything else that we do, the very first thing that we need to do is to calibrate it. So the way you calibrate it is that you run room air through it, and then you run a calibration gas through it. So this has two different ports, one for room air and one for the sample line. And in this case, we're going to put the calibration gas through. There are two filters on each port, and the reason for that is you don't want any contaminants coming in and getting into the sensors. So it is going to draw air in through the room air side for 10 seconds. Then it's going to draw air in through the sample size. The calibration gas is going to go through the sample side for approximately 15 seconds, and then based on that, it's going to calibrate, and then we know that we're going to get accurate readings. So when we calibrate, we actually use a calibration gas that's on the other end of the physiological spectrum. So we know that room air is 20.93% oxygen and 0.03% carbon dioxide. We know when we're doing our VO2 max testing in our breath hold, CO2 won't drop below or won't go above 5%, and oxygen shouldn't drop below 15%. So what we have is we have a calibration gas that has 15% oxygen and it has 5% CO2. So that gives us our physiological range. The maximum is going to be 20.93% oxygen and 0.03% carbon dioxide. And on the other end of the spectrum, we're going to have 15% oxygen and 5% CO2. So to calibrate this, it's relatively straightforward. What I've opened up here is I've opened up a file that will allow us to monitor the gas. So I've opened up a setting that we're actually going to use for the VO2 max test, but this file will allow us to look at CO2 continuously, and it allows us to look at oxygen continuously, and then based on that we're able to determine what our oxygen and what our CO2 concentration is. So on the screen here in real time you'll see what the oxygen and the CO2 concentration is. Then we can go back with our single cursor and measure what that value actually is. So the very first thing that you need to do to calibrate it is you just simply click on the Calibrate Gas Analyzer button. So we click on the Calibrate Gas Analyzer button. It says, would you like to do a calibration? We say yes. And then it says, has the gas analyzer warmed up for 15 minutes? So for any gas analyzer, you typically want to have it warming up for at least 15 to 20 minutes, and there's a lot of gas analyzers that just stay on continuously. So we say yes, it has warmed up for 15 minutes. It typically won't even allow you to open up the program if the gas analyzer hasn't warmed up. The next thing it will do is it will give you some instructions to make sure that everything is set up correctly. So it's saying, is there a filter on the gas analyzer for room air? Is there a filter on the sample line? Have you hooked up the correct tubing for the sample line? Is this Nafion end on the sample line that's coming in as well? So it's just saying, have you hooked up everything correctly? You make sure it's hooked up correctly, you click next. Now what it's doing, it is sampling room air. So right now room air is going in there and it is sampling what the oxygen and CO2 concentration is of the room air. Now it's saying it wants to calibrate using the calibration gas, so it's telling us to open up the calibration gas. So in order to do that, what we have here is we have a large cylinder that has calibration gas in it. You have to keep in mind that this is under a tremendous amount of pressure. So there's a 2-valve system to open this up. So the first larger valve will open up the gas so that the gas can go from the cylinder into the regulator. So this can be as high as 2,500 pounds per square inch. So now this gas is going into the regulator. I set the regulator so that I have the right amount of flow coming out. So I've set it at 16 pounds per square inch. So now when I open up this line, there's 16 pounds per square inch of air flowing through there. If I had this hooked up directly into the cylinder, I would have way too much pressure, so it's important to step it down. So in order to utilize this gas, you open up the large valve first, then you're able to control the flow using the smaller valve. Now all we need to do is we need to take the end of our sample line, and the connection here, it's a 3-way or a T connection. It just simply locks in place. There's also a port here that allows any excess pressure to escape because we do not want to overpressurize the gas analyzer. So all we do now is we just open this up, and you can hear that there's air flowing through there. So we know now that the air is going into the gas analyzer and it's able to sample the sample gas. So it's saying, have you hooked up to the calibration gas? Is it flowing? We say yes. And now what it's going to do, it is going to analyze the calibration gas, and it's going to do it for 20 seconds. So here you can see how the CO2 has increased. It's approximately 5%, and you can see the oxygen has decreased down to about 15.6%. So it'll sample that for 20 seconds. And when it's done, it'll tell us to turn off the sample gas. So what I typically do is turn the cylinder off first, and then that allows any excess pressure to bleed through. And now I can close this line. And now we're able to sample our gas, and we know that it has been calibrated, and we should get a fairly accurate reading based on our calibration. So the last step that you do is you just click next. And then what it says on the screen, this was the room air that we sampled. Then 2 cursors over that. This was the calibration that we sampled. There's 2 cursors over that. So you just want to ensure that it is calibrating from the correct locations. Then the last thing that you need to do is you need to put in what the calibration gas percentage was. So you're going to say that the calibration gas oxygen was 15.5%. And you're going to say that the CO2 is 5.06%. It's saying the room air is 20.93% and the CO2 is 0.04%. It does 0.04 instead of 0.03 because just us standing around, we're probably going to have an increase in CO2. So now all you need to do is click OK. And now it is ready to sample. And all you need to do to sample a gas is just click record. Then as you click record, it is going to be continuously drawing in air and sampling that air. So right now you can see this was the calibration gas that's just passing through. This is what our value is. It's reading now for CO2 is 0.05%, and oxygen it's reading 20.84%. And you can see this is pretty sensitive and it's always doing a little bit of fluctuation. So for what we're going to be doing today, we're going to be measuring end tidal, CO2 and O2 concentrations. So the way you're going to do that is you're going to hold this at the front of your mouth, and then you're going to breathe out fully. You're going to breathe out as much as you can. So the key thing there is not have it too far out so you're bringing in other air. You obviously don't want to push it too far into your mouth. You're just going to breathe out. And as you do that, it is going to continuously measure the oxygen and the CO2 concentration. So in order to get those values, we click stop. We go to the single cursor, and then we move the single cursor to the peak for the CO2 and the oxygen. So right now, that's the peak of the CO2, and it's saying the CO2 percentage was 3.09% CO2. So my maximum CO2, my end tidal CO2 was 3.09%. You may need to move this back a little bit, but our lowest oxygen concentration was 17.65%. So that is how you're going to monitor your CO2 concentration and how you're going to monitor your O2 concentration. So as you're doing this, you can have this continuously run. Or you can, just before the subject is going to breathe into it, you can start the recording so that you can calculate what the CO2 and what the oxygen concentration is. You can also, just as in our other programs, you can add marks as we're going along. So it's relatively straightforward, it's easy to use. You don't need to save this file, we're just going to record what our oxygen and CO2 concentrations are. So the last thing I want to go over with you is how we're going to fill up this bladder to get 100% oxygen inside this bladder. So if we go over here, we have a cylinder with 100% oxygen in. So it works under the same principle. Unfortunately, it's a slightly different regulator, but it works under the same principle. So the first thing I'm going to do is I'm going to open up the cylinder. And now I can see this is the incoming pressure. Right now it's at about 1,300 pounds per square inch. But the outgoing pressure is only around 60 pounds per square inch. So I've opened this up, I've pressurized this. I'm going to take this clamp off this end, and what I'm able to do is I'm able to take the line from the oxygen, I'm able to place it in there. And now if I open this up, I'm able to fill up the oxygen bladder. I'm able to shut that off. And I'm going to clamp this off. So now I have a 10-liter balloon that has 100% oxygen in it. So when you go to do the 100% oxygen, the best way to do this is you're going to put your hand over it, you're going to pull out the stopper, you're going to breathe out, and then when you're ready, you're going to breathe in 100% oxygen. So you may mess it up the first time you do it, don't worry about it, do it the second time, but the whole concept here is this is going to be full, you're going to put this in your hand, you can squeeze it off, you're going to pull the cork out, blow out as much air as you can, and then you're going to breathe in 100% oxygen, then you're going to hold your breath as long as you can. Good?